This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. Data encapsulation is the process of surrounding or encapsulating our data with networking information so that it can get to its destination over the network. Now, we already talked about how at layer 5, 6, and 7, the data is still just the data. It might be manipulated a bit, but it's the data. By the time it gets down to layer 4, the data is done being manipulated, and we're going to encapsulate it. And when we do this, it turns into a segment. At layer 3, it becomes a packet or datagram. At layer 2, it becomes a frame. And at layer 1, when it's actually being transmitted across a wire, it's called a bit. So let's take a look at each encapsulation process. So again, layer 7, 6, and 5, we've just got our data here. Then at layer 4, this data has a header added to it, and that makes it a segment. It's going to have a source port and a destination port. We're definitely going to be talking about ports more when we talk about TCP and UDP, but just as an example, if I was making an HTTP request, the destination port would be port 80, and the source port would actually be selected by normally TCP if we're making an HTTP request, and it's actually going to be a port over 1024 selected by TCP, but we'll talk about that more later. But the bottom line is a source port and a destination port is added to our data, and that makes it a segment. Then at layer 3, another header is added, and that makes it a packet. It has a source IP, a destination IP, and a protocol. And the protocol basically says what protocol is being encapsulated by this packet. And the source IP and destination IP are probably self-explanatory. Whatever the IP address of the destination is, that's going to go here, and the source IP is who we are if we're sending this packet out. So if my IP address is 192.168.6.100, that's going to be my source and IP, and if I'm trying to send this packet to 192.168.6.50, then that's going to be the destination IP. This header is also called a control header. Then we make our way down to layer 2, and the packet is encapsulated, and it becomes a frame. The destination MAC address is added, along with the source MAC address, the ether field or type. We're going to talk about this more when we talk about Ethernet. And then FCS, which stands for Frame Check Sequence. And this is added so that we can perform error detection on this frame to make sure there wasn't any kind of corruption as it transferred over the network. And then this frame is turned into bits and transferred over whatever medium we're trying to transfer it over, like an Ethernet cable. Once it gets transferred over the medium and reaches its destination, it gets decapsulated. So layer 2 takes these bits, turns them into a frame. Then at layer 3, it strips off our header and our FCS, our checksum, and then it becomes a packet. And then it gets handed to the proper protocol at layer 4, and the layer 3 header gets stripped off, becomes a segment, and then the segment header gets stripped off and it gets handed back up to layer 5, and then it's just data. So it's been completely decapsulated. And this process repeats over and over and over again as we're sending and receiving data over the internet or over our network.